She is NASA's modern-day Icarus. Luckily, the Parker Solar Probe didn't burn up as it made another close approach to the Sun. Having already ventured as close as 13 million kilometers in 2023, the spacecraft is now on track to surpass its own record, coming within just 6 million kilometers of our radiant star. The data gathered during this mission is offering an entirely new perspective on the Sun. How can this even be possible? How does a probe venture into such an intense cosmic inferno without being instantly incinerated? And how did it succeed in unraveling a perplexing solar wind mystery that has baffled scientists since the 1960s? For many of us, the Christmas season is a time for warmth and reflection, but the Parker Solar Probe had a very different experience on Christmas Eve. December 24, 2024, was a record-breaking day for the spacecraft. NASA revealed that its Sunstriker had reached an astonishing speed of approximately 690,000 kilometers per hour, making it the fastest human-made object to travel through space. At the same time, this incredible velocity brought the probe within just 6 million kilometers of the Sun. This meant it had set a new record for the closest approach to the Sun. However, NASA experts had to wait until December 26 to finally celebrate. Following the remarkable flight, there was a full day of radio silence. But on Boxing Day, a signal reached the U.S. Space Agency, confirming that the Parker Solar Probe had emerged from the Sun's grasp unharmed and was functioning as expected. The probe successfully began transmitting its initial telemetry data to Earth just in time for New Year's Day. In a mission update the following day, NASA confirmed that the Parker Solar Probe's scientific instruments remained fully intact. Additionally, the dataset indicated that the flight computer's programmed commands had been executed as planned. What groundbreaking discoveries might be concealed within the new data? According to Helen Winters, program manager at Johns Hopkins University in Baltimore, the spacecraft has been capturing observations never before possible. However, the somewhat disappointing reality is that the insights from the Parker Solar Probe remain unknown for now. Thankfully, this isn't due to an unexpected transmission error but simply because the rest of the data won't reach Earth until the end of January. This will occur only when the most powerful onboard antenna is optimally aligned with Earth, enabling higher transmission rates. While experts eagerly await the outcome of this crucial rendezvous, the future holds even more excitement. The Parker Solar Probe is set to make 2 additional close approaches to the Sun this year, on March 22 and June 19, maintaining similar speeds and distances. Reflecting on its journey, the probe has already provided extraordinary insights into the Sun, unveiling it from a completely new perspective. How the Parker Solar Probe will withstand its journey to the Sun. The name Parker in the Solar Probe's title is no accident. It honors U.S. astrophysicist Eugene Parker, who gained recognition in the 1950s as a young scientist for proposing a mathematical theory that explained the existence of the solar wind. Simply put, the solar wind is a continuous stream of charged particles emitted by the Sun into space. Eugene Parker, who passed away in 2022 at the age of 94, was the first to witness the launch of a space probe bearing his name. The Parker Solar Probe embarked on its journey into space on August 12, 2018. But what led to its mission toward the Sun? And how has it managed to withstand the intense heat? Regarding the mission's objective, it's important to remember that several major uncertainties remain about the Sun specifically. We still need to understand why the solar corona is extremely hot, how the solar wind is produced, and what causes its high speed. The heat distribution of celestial bodies, such as Earth, typically moves from the interior outward, meaning temperatures gradually drop from the core to the outer layers. However, the Sun presents an intriguing exception with its corona, a secondary heat zone. But what causes the Sun's outer atmosphere to reach an astonishing temperature of about 1 million degrees, over 200 times hotter than its surface? Because the second law of thermodynamics dictates that heat cannot flow from a cooler area to a warmer one, the intense heat of the solar corona must originate from another source. This means the heat must be generated within the corona itself. However, when scientists realized they couldn't solve this mystery using only Earth-based research, they chose to send the Parker Solar Probe directly into the solar corona to investigate. The reason it didn't share Icarus's fate and burn to ashes can be attributed to several fascinating factors. Most importantly, in physics, temperature and heat are not the same. Temperature indicates the kinetic energy of particles, reflecting their speed, whereas heat refers to the total energy transferred between particles. In the solar corona, individual plasma particles move at extremely high temperatures. However, because they are sparse, the Parker Solar Probe only needs to endure temperatures of around 1,400 degrees Celsius. This is made possible by a large heat shield composed of carbon foam and carbon plates, coated with a highly reflective white ceramic layer. To protect the other components, NASA specialists have once again employed specialized materials, such as advanced alloys and sapphire conductor tracks, which can withstand temperatures far beyond the expected range. Parker Solar Probe's discoveries about the Sun.